Dear students, now we are going to see the course Signals and System. Under that, the topic is sampling. Upon the completion of the course sampling, the students can able to discretize the signal using sampling. Sampling is the process of converting the continuous time signal into discrete time signal. So the sampling is done by a product modulator or a mixer. The mixer, it combines the continuous time sinusoidal with signal with the train of impulse signal, and the output is the sampled signal. The sampled signal is represented by x of n t. The theorem is sampling theorem states that a band limited signal x of t with x of omega is 0 for the modulus of x of omega is greater than or equal to omega m, that can be represented and uniquely determined from its sample x of nt if the sampling frequency fs is greater than or equal to 2 fm, where fm is the frequency component present in x of t. For signal recovery, the sampling frequency must be at least twice the high frequency present in the signal, so fs is greater than or equal to 2 fm. Sample signal gives us xs of t equal to x of t into del t of t. So we know that del t of t equal to summation n equal to minus infinity to infinity del of t minus nt, that is equal to 1 by t summation n equal to minus infinity to infinity e power j n omega st. Substitute the del of t in the sample signal. So the sample signal x of t equal to x of t into 1 by t summation n equal to minus infinity to infinity e power j n omega st. Applying the Fourier transform on both sides of the sample signal, so we are getting xs of omega equal to 1 by t summation n equal to minus infinity to infinity Fourier transform of x of t e power j n omega st. So Fourier transform gives 1 by t equal to 1 by t summation n equal to minus infinity to infinity x of omega minus n into omega s. Here omega s is the sampling frequency, which is equal to 2 pi fs, that is equal to 2 pi by t. Xs of omega is also expressed in terms of 2 pi by t, so omega is replaced by 2 pi by t. So 1 by t summation n equal to minus infinity to infinity x of omega minus 2 pi n by capital T. Here the sampling frequency fs equal to 1 by t. So xs of f, that is the sample signal in terms of analog frequency fs, given as fs summation n equal to minus infinity infinity x of f minus n into fs. Here the x of omega or x of f is the spectrum of the input signal. Xs of omega or xs of f is the spectrum of sampled signal. The spectrum of the input signal is given as the figure 4.5. Here the omega value ranges from minus omega m to plus omega m. So its bandwidth is 2 omega m. Now the first condition is the signal frequency omega s must minus omega m value is greater than omega m, that is oversampling. Here there is a band gap between the adjacent sample spectrum of the sampled signal, so this reduces the interference. Second condition is if omega s minus omega m is equal to omega m, here there is no gap between the input spectrum as well as the sample spectrum, but anyway the possibility of occurrence of interference is minimum in this case. Then undersampling, that is omega s minus omega m is less than omega m. In this case the high frequency component of the input spectrum is overlapped with the low frequency component of the sampled spectrum. This causes aliasing. Okay, then signal recovery, omega s minus omega m is greater than omega m, that means omega s is greater than 2 omega m, or fs is greater than or equal to 2 omega m for a lossless signal recovery. Aliasing, a high frequency component in the frequency spectrum of signal takes identity of a low frequency component in the spectrum of the sample signal when the sample frequency fs is less than 2 fm, that is the input signal is undersampled, the individual terms in the equation get overlapped. Aliasing occurs due to if the signal is not band limited to a finite range or if the sampling rate is too low. The conditions to avoid aliasing is the signal x of t should be strictly band limiter, and it can be ensured by using anti-aliasing filter before the sampler. Fs should be greater than 2 fm. Nyquist rate Fn equal to 2 fm Hertz. Quiz: which of the following is true when sampling time less than Nyquist interval? If the sampling time is less than the Nyquist interval, then the original signal is recreated. Thank you for watching.